Circle concept overviews. In this video, I'm going to represent for you some important definitions and rules related to the circle. First, circle is a closed curve equidistant from a point inside it which called the center, And the name of the center is give me the name of the circle. For example, if this center is M, the circle is called M. The length between the vertex, which is the center, and any point on the circle is called radius. Chord, it's a line segment joining between 2 points on the circle but not passes through the center. Diameter, it's the line segment joining between 2 points on the circle and it's equal to radii and also passes through the center. Tangent, it's a straight line which only touch the circle at one point, not more than 1 point. And the tangent is perpendicular to the radius. Again, if I draw a tangent, touch the circle, so if you join between the point of tangency and the center of the circle, this angle is equal 90 degrees because the radius is perpendicular to the tangent from the point of tangency. So this is all is the segment of the circle and its definition. Notice that all the radii of the circle are congruent. All the radii of the circle are congruent. Let's go to the second part. A radius that is perpendicular to a chord bisects the chord. A radius which is perpendicular to the chord bisects the chord. What the meaning of the word bisects? Bisect, it means divide it into two equal parts. Into two equal parts. So if C, for example, is perpendicular to BA, it means that AC is equal to BC. If OC is perpendicular to AB, then AC is congruent to CB and equal in length. Next one, length of the arc and the circumference of the circle. Circumference and length of the arc. Arc is a part on the circle, okay, which represent a length of the circumference. Circumference of the circle is 2 pi r, and pi here is approximately 3.14 or 22/7 as a length. The arc which represents half of the circle is called semicircle. Semicircle is the arc which represents half of the circle, like AB from the left or AB from the right. The arc AC called minor arc, small one, but the arc from C to B to A, joining between the 3 points CBA, is called major arc. Major arc because its measure is greater than 180 degrees. Minor arc because its measure is smaller than 180 degrees. And the one that equal to 180 is called semicircle. Circumference of the circle is 2 pi r. For example, I have a circle, its radius is 4, and I wanted to find its circumference. So radius is equal to 4, so 2 pi r, 2 pi 4, which is equal to 8 pi in terms of pi. It means I'm not going to replace the value of pi. How we can figure the arc length? As we said, the arc length is represent a part out of the circle. So the arc length is the angle divided by 360 to give me the ratio which the arc represent, multiplied by 2 pi r. And measure of the arc is equal to the measure of its opposite central angle, or we can say that measure of the arc is equal to the measure of the intercepted central angle. Intercepted central angle. So for example, if this angle is equal to 60, this is a central angle, its measure is equal to 60, so the measure of this arc is equal 60. And notice that if we set arc AB only, it means that we looking for the minor arc, or we point at the minor arc if we set only arc AB. So if the measure of the arc is 60 and I wanted to find its length, it will be 60 divided by 360 multiplied by 2 pi r. But what about the area of the circle? Area of the circle, it means all the points that inside and on the line of drawing the circle. So it's on the point inside and on the circle, union of all of these points. And the area of the circle is pi r square. Pi r square. For example, if I have a circle with radius 5, 5 square is 25. So I can say directly that the area is 25 pi. But what about if I wanted to find the area of the sector? What is the sector? Sector is the area bounded by two radius and arc. Region area between two radius and arc. Like the slice of the pizza. Slice of the pizza, we called it sector. How we can find the area of this sector? We divide the angle by 360 and we multiply it by the area of the circle. So it's theta divided by 360 multiplied by pi r square. Example, how I can find the area of the same arc that have measure of angle 60. So this arc, its measure is 60 degrees. So 60 divided by 360 multiplied by pi r square. So 60 over 360 multiply 3 square, which is equal to 3 over 2 pi. Another title, inscribed angles in the circle and the difference between central angle and inscribed angle. If you have a circle and you have a point on it and you join between two chords, these are not diameters, this angle is called inscribed angles. But the angle that comes from the center of the circle and its two sides are two radii is called central angle. So central angle is the one come from the center. Inscribed angle is the one that comes from the intersection of the intersection of two chords, and its vertex lies on the circle. What the relation between the inscribed angle and the opposite arc? The inscribed angle is equal half the measure of the opposite arc. For example, if this is 2 theta, the measure of this arc is 2 theta. If this arc is 100 degrees, so this angle is 50 degrees. So the measure of the inscribed angle is half the arc. And we all know that the measure of the central angle is equal to the arc. So measure of the inscribed angle is half the central and half the arc. Again, central angle is equal measure of the arc. But inscribed angle is equal half its intercepted arc.
Mr. Circle theorems, yeah?
Okay. The inscribed angle that have the same arc are congruent, and the angle that it's drawing in a semicircle are congruent. Let's explain for you this part. If you have a circle, if you have a circle and you drew an inscribed angle here, subtended by this arc, and you drew an inscribed angle there, these two angles are equal. Why? Because they have intercepts by the same arc. They have intercepts by the same arc. Something else, if you have a circle, and this circle, you draw a diameter, this one is an inscribed angle, but it's opposite to semicircle. The opposite arc is 180 degrees. So this angle is a right angle. So this angle is a right angle. So the angle drawing in a semicircle or opposite to a diameter, its measure is equal 90 degrees. Two tangents to a circle. As we defined before, tangent is a straight line which touches the circle at one point. Tangent is a straight line like P3. It's a straight line which touches the circle at one point. And from a point outside the circle, you can only draw two tangents. From a point outside the circle, you can draw only two tangents. For example, AB and AC are two tangents drawn from the point outside the circle. So AB and AC are congruent. And you can't draw more than two tangents from the point A. You can't draw more than two tangents from the point A. Something else, we said that the radius is perpendicular to the diameter from the point of tangency. So this angle is 90, and that angle is 90. So for sure, the sum of angle A and angle M, measure of angle A plus measure of angle M, should be 180. Why? Because the sum of the angles of the quadrilateral is 180. So these two angles are supplementary, because angle B plus C is equal to 180. For example, find the area of the triangle AOB. Find the area of the triangle AOB, where AB is a tangent to the circle below. So this angle is 60, this angle is 90, so this angle is 30. The side opposite to the angle 30 is equal √3 multiply the side opposite to the angle 30. So AB is equal 3√3. So the area of the circle is equal half base, which is 3, height is 3√3, so it's 9/2√3, which can be written as 4.5√3, and the area of the triangle is equal half base by height, half base by height.